Okay, so today we'd like to graph the data we collected yesterday. So here is the data that I collected when I did it from my own program. Okay, for the ideal bulb, I have my data in red, and for the real bulb, I put my data in purple. I happen to use the same voltages for each bulb, but you did not have to do that. So go to the Quick Graph program and start out by graphing just the ideal bulb. It should look something like this. It should be a proportional relationship, so you want to hit curve fit and pick proportional. We now want to do something that we don't use very often. We want to click on the word dataset1 right above the equation. We want to call that the ideal bulb. We then want to make another data set, so we say change data set, and you'll see it brings up a whole new set of points that you can type in, and it changes the color. We can click here before we forget and call this the real bulb. We then want to enter in our numbers. Okay, and when we're done, we should see our blue data plotted on the same axes as our red data. This time when we curve fit it, I want you to realize it is not a simple curve fit. The relationship is not one of our simple relationships. We will learn tomorrow just how complicated these relationships can be. However, a square root graph will almost fit our data. So realize this is not the real equation, but it is kind of close. Okay, you can see it has the same general shape as my data. I'm going to override it and try and make it even better. So I'm going to get rid of what's in here to start with. And I'm going to try to adjust my number to get it fitting closer to the actual data. Okay, when I'm done, I want to expand this, and I want to put these two graphs, make sure you do it in different colors, onto your lab sheet, and make sure you understand the difference between the ideal and the real. The ideal shows a perfect linear relationship, and the real bulb shows a more complicated relationship. So what is happening here that you could add to your conclusion is that with our ideal bulb, we assumed that it had the same resistance no matter what the conditions were. With a real bulb, the resistance of the bulb changes with conditions. So where the slope is steep, that means a low resistance, and where the slope becomes more gentle, like at the end, it means a higher resistance. It takes a bigger change in voltage to create a noticeable current change. We will learn in a little more detail exactly what's going on during tomorrow's notes.